Hello everyone. In this video, we focus on combinations. Let's take a look at its definition. Given a set of n distinct objects, a combination of a set of objects is an unordered subset formed from the set of n distinct objects. Unordered subset, that is, order does not matter. For example, we choose three letters. Suppose the letters A, B, C are chosen. We can have a sequence like A, B, C, or we can have a sequence A, C, B, or the sequence B, C, A. The orders are not the same for the three sequences. However, they refer to the same combination. As long as we have the same elements in our list, then the sequence does not matter and all of them refer to a single combination. Let's take a look at the following. Choose a set of three elements from the list of 5 letters A, B, C, D, and E, and assign the selected elements in one group. If we consider permutations, there are altogether 5p3 equals to 60 permutations. How about combination? Suppose we choose the three elements as A, C, and D. We can have different orders. For example, we can have the sequence ACD, ADC, CAD, CDA, DCA, and DAC. All these 6 permutations consist of the same letters A, C, and D. Therefore, when we are talking about combinations, all these 6 different sequences refers to the same combinations. If we select R elements, a total of R factorial permutations all refer to the same combinations. So how many combinations can we obtain by selecting 3 elements from the list of 5 elements? For example, the letters A, B, and C are selected, then we can have 6 different permutations. However, these 6 permutations all refer to a single combination, A, B, C. And suppose 3 letters A, B, D are selected. We also obtain 6 permutations from the 3 letters A, B, and D. However, they all refer to a single combination ABD. Proceed similarly. We can obtain 10 different combinations. How do we get the numbers 10? The number of combinations here is equals to 5p3, the total number of permutation, divided by 3 factorial. The number 3 factorial equals to 6 is the number of permutations, refers to a single combination. So here we get the number 10. 10 different combinations can be obtained by selecting 3 elements out of 5. The number of different samples of R elements that can be selected from n elements is denoted as the symbols NCR. C stands for combination. Or in some other reference, you can see that we have a bracket and N on the top and R at the bottom. The 2 symbols are equivalent. And we have the formula here. NCR is equal to NPR divided by R factorial. Recall the formula of NPR. NPR is equal to N factorial divided by N minus R factorial. Together with the denominator here with the R factorial, NCR is equal to N factorial divided by R factorial by N minus R factorial. Let's take a look at some symmetry of combinations. In combinations, sampling is equivalent to partitioning a set of n elements into 2 groups. The elements we select in the sample and the elements that we do not select in the sample. So choosing our elements out of n elements is equivalent to not choosing n minus r elements. So here we have n elements. We choose r of them. And the number of different elements that we can choose is NCR. And it is the same as on the left-hand side, the n minus r elements are not selected. And the number of ways of not choosing n minus r elements is NCn minus r. So NCn minus r and NCR should be the same. They are equivalent. So let's take a look at it using the formula. NCR is equals to NPR over R factorial, which is equals to N factorial divided by R factorial by N minus R factorial. How about the simple NCn minus R? We simply replace the R in the NCR formula by the expression N minus R. So NCn minus R is equals to NPn minus R over N minus R factorial. This is equals to N factorial divided by N minus R factorial by N minus R factorial. Simplifying it, we get N factorial over N minus R factorial by R factorial. And you can see that NCR is equals to NCn minus R. This is one property or one symmetry of combinations. And then some properties. NC0 is equals to NCn equals to 1. What is NC0 refers to? We select 0 elements out of n elements, and we can only have one way of choosing it. This one way is not choosing anything. So we have NC0. And it is the same as the value of NCn, choosing all n elements out of a box of n elements. So again, we have one way of doing it, is to choose everything from the list. So NC0 equals to NCn equals to 1. In terms of the formula, NC0 is equals to n factorial over 0 factorial by n minus 0 factorial. And 0 factorial by definition is equals to 1. So here NC0 is equals to n factorial divided by n factorial, which is equals to 1. And then NCn, here we have n factorial divided by n factorial by n minus n factorial. So n minus n is 0. So we have 0 factorial again. The value is 1. So here we have NCn equals to 1. And then we have the third remark. Okay, NC1 is equals to NCn minus 1 equals to n. And we can verify this using the formula as well. So NC1 is equals to n factorial over 1 factorial by n minus 1 factorial. And this is also the expression for NCn minus 1. So upon simplification, we get NC1 equals to n. Let's take a look at an example. In how many ways can an executive committee of 5 be chosen from a board of directors consisting 15 members? So here, the order does not matter as long as we get an executive committee of 5, then we are done. So this is a problem using combinations. We have the formula NCR. So what is the value of N and what is the value of R? We choose 5 out of 15. So N is equals to 15 and R is equals to 5. Plugging it into the formula, we have an expression 15C5 equals to 15 factorial over 5 factorial by 15 minus 5 factorial, which reduces to 15 factorial divided by 5 factorial by 10 factorial. Upon calculation, we get the number of combinations equals to 3003. That's it for today's video. Thank you for watching. In the next video, we will give you more and more examples on counting technique.